Hey everyone, and welcome. We're about to take a massive journey from right here on Earth all the way out to the far reaches of our solar system. We're going to find out why our planet works the way it does. So let's jump right in. First things first, a question for you. Have you ever really thought about why you get to enjoy a long, sunny summer vacation, but you're all bundled up in a coat for school in the winter? It might seem simple, but the real answer is actually one of the biggest myths in science, and it all comes down to how our planet moves. Okay, so to get this, we've got to get two key movements down: rotation and revolution. First up is rotation. That's the Earth spinning on its axis, kind of like a basketball on your finger. One full spin takes 24 hours, and that, my friends, gives us day and night. Simple enough, right? Then you've got revolution. That's Earth's massive year-long trip around the sun. One full orbit takes 365 days, which gives us 1 year. So it seems logical, right? Summer must be when we're closer to the sun, and winter is when we're farther away. Well, I'm here to tell you that is 100% wrong. It's probably the biggest misconception out there. In fact, for those of us in the northern hemisphere, the Earth is actually a little bit farther from the sun during our summer. So what on earth is really going on? The real reason, the absolute game changer for our seasons, is this: the Earth is tilted. Yep, our planet doesn't spin perfectly upright. It's leaning over on its axis by about 23.5 degrees. And that little tilt, it changes everything. So here's how that tilt works its magic. When your half of the world, your hemisphere, is tilted towards the sun, you're getting more direct, concentrated sunlight. It's like having a flashlight shine straight down on you. The days get longer, it gets warmer, and boom, it's summer. The peak of that is the summer solstice, the longest day of the year. Now, when your hemisphere is tilted away from the sun, that same sunlight hits you at an angle, spreading it out. The days get shorter, it's colder, and that's winter. The shortest day, that's the winter solstice. It's all about the tilt. Okay, let's bring our focus a little closer to home and talk about Earth's best friend, our closest cosmic neighbor, the moon. It's our one and only natural satellite, and the way it dances around our planet creates some seriously cool sights in the night sky. Now, the moon isn't a light bulb. It doesn't make its own light. What we see is just sunlight reflecting off its surface. As it makes its 28-day trip around the Earth, we see different parts of that sunlit side. We call these the phases of the moon. It all starts with a new moon, where we can't see the lit side at all. Then it grows to a half moon, then to a beautiful full moon where the whole face is lit up. And then the cycle starts all over again. But every once in a while, something really special happens. The sun, the Earth, and the moon, they all get into a perfect straight line. And when that cosmic alignment happens, well, that's when we get an eclipse. Okay, picture this: sun, then moon, then Earth. When the moon passes right between the sun and us, it literally blocks out the sun's light and casts a shadow on our planet. For a few incredible moments, day turns into twilight. That is a solar eclipse. It's a pretty mind-blowing event when you think about it. So what if we flip that lineup? What if it's sun, then Earth, then moon? Well, in that case, our own planet gets in the way and blocks the sunlight from reaching the moon. Earth's shadow falls right across the moon, and it often turns this deep, beautiful reddish color. That, my friends, is a lunar eclipse. All right, now that we've covered our little home system of Earth and moon, let's zoom the camera way out, because we are just a tiny part of a much bigger family. It's time for a quick tour of our cosmic neighborhood, the solar system. So our solar system is made up of our star, the sun, and everything that orbits it. That includes 8 planets. In order, starting from the sun and moving out, we've got Mercury, Venus, Earth, and Mars. Then there's this big gap called the asteroid belt, separating the inner planets from the outer giants: Jupiter, Saturn, Uranus, and Neptune, way out at the edge. And these planets basically come in 2 flavors. The first 4, Mercury, Venus, Earth, and Mars, are called the rocky planets. They're smaller, and they're made of solid rock and metal. The 4 outer planets are the gas giants. Jupiter, Saturn, Uranus, and Neptune are absolutely enormous and are made mostly of gas. They don't even have a solid surface you could stand on. And get this, our whole solar system is just one tiny speck in our galaxy, the Milky Way. And our galaxy is just one of billions out there. The distances are so insane that we can't even use miles or kilometers. We have to use something called a light year. Now, this is important. A light year is a measure of distance, not time. It's the distance light can travel in an entire year, and it is unbelievably far. So, what keeps all these planets and moons and stars from just flying off in random directions? What holds the entire universe together? Well, the answer is an invisible force that acts like the universe's cosmic glue. And that force, of course, is gravity. It's this fundamental force of attraction between any two objects that have mass. The sun is so massive that its gravity is strong enough to keep all 8 planets in a constant orbit. And Earth's gravity is what keeps the moon circling us, and, just as important, it's what's keeping you in your seat right now. Now, gravity brings us to another super common mix-up, the difference between mass and weight. Your mass is literally the amount of stuff you are made of. It's measured in kilograms, and that number never, ever changes no matter where you are in the universe. Your weight, on the other hand, is the measurement of gravity's pull on your mass. It's measured in newtons, and it totally changes depending on where you are. Let me show you what I mean. Just look at this chart. Let's say your mass is 40 kilograms. Here on Earth, your weight is about 392 newtons. But if you could travel to the moon, where gravity is way weaker, your mass would still be 40 kilograms, but you'd only weigh 64 newtons. You'd feel super light. Your mass is always the same, but your weight depends on gravity. So all this talk about distant planets and invisible forces might seem, well, distant. But our desire to explore space has actually led to some incredible technology that you and I use every single day, probably without even thinking about it. Seriously, ever use GPS on your phone to get somewhere? You can thank space tech for that. That whole system relies on satellites. How about checking the weather forecast? Also made possible by satellites tracking storms from above. Even your phone calls and TV shows are often bounced off satellites orbiting the Earth. And right now, the International Space Station is flying over our heads, a massive lab in space where science is happening that helps us all. So, you see, the big takeaway here is that studying space isn't just about cool pictures of galaxies. It's about pushing science forward. It's a journey that actually teaches us more about our own amazing planet and leads to real-world inventions that make our lives better right here at home. And all of this leaves us with one last, huge, exciting question. With all that's still out there to explore, from new planets to the very beginning of the universe itself, what do you think is the next great discovery waiting for us out there in the stars?
If you enjoyed this video, please like and subscribe.